Now let this distance be 2d and this is d. So I want at origin. So look at the orientation of bar magnets. They are oriented in this way. You have to calculate the field at origin. So where is the origin now? It lies on the equatorial line. As it lies on the equatorial line, so first we'll call this as bar magnet 1. This is 2. So the resultant field BO should be equal to due to first bar magnet should be opposite to that. So minus of mu naught m by 4 pi d square. Due to this, due to second bar magnet, it should be opposite to that, mu naught 2m 4 pi d square. If take subtract here, mu naught m by 4 pi d square. So what is the direction of this? It will be towards right. I can keep the orientation of bar magnets in any way. So more than one bar magnet will be there. They'll ask you to calculate the field at a given point, and you check this type of question. There are around, I think, more than. Okay, I think okay 2D. Okay, this is 2D whole square. So then how much it will be? 1 by 2, 3 mu naught. Okay, then I think some calculations will come. Mu naught m by 4 pi d. I'll take outside. 1 by 2 will come. Minus 1 minus 1 by 2. Is it okay this? No? Towards left? Huh? Might be towards left. I didn't check that 2D that one. Now the bar magnets can be oriented. Okay, just see once. I'll scroll down. So let me take another situation. Now you have to calculate the field at the origin. Direction of m bar is given. This distance is 3d. You have to calculate the net field at the origin. So call this bar magnet 1. This is 2. So due to B1, it should be towards left. Due to B2, it should be along positive axis. The resultant field will be given by, first we'll calculate this one. So mu naught. Where is the point? Point lies on axial line. No? So 2 times will come. 2 times mu naught 2m 4 pi 3d whole square. B2 should be equal to mu naught 2 times m 4 pi d whole square. At origin is asking the resultant field. And how these two are? This is along positive x-axis. This is along positive axis. So the resultant field will be b1 square plus b2 square. Any orientation, let it be any orientation. Just you take the b bar is a vector, so the vector sum is what you have to take. So what about port strength? Say magnetic charge is a scalar again. Like how we have charge scalar, no? Similarly, magnetic charge or port strength is also a scalar. Somebody is asking that port strength is a scalar. Okay, this is some generalized different types of questions will be coming for us, and also you can, I just took the 2 magnets or 3 bar magnets, they can bring 3 also, 2, 3 orientation, different orientation. Now if it's some generalized, if they ask you some arbitrary, you have to use this formula, electric dipole based formula here. It's an arbitrary, that one. Last one more. What should be the net field at point O? So for that, what happen? The net field at point O should be 0. For that, what should be the m naught? Or I'll put some m dash. Find m dash at origin must be 0. Yes, given distances d and that one. So first there's a dipole 1, bar magnet 1. Due to that, the field will be downward. Due to this also, the field will be downward. Okay, got this. Now m dash is like this. So the field due to this will be upward. Where is this line? What is this line? This is some sort of equatorial line. On equatorial. But sir, you said y-axis equatorial. Look at the orientation of bar magnet. The m bar is along y-axis. Then x-axis will become equatorial and this will become axial line. The axial line for this bar magnet will come here. This will become equatorial line. So the net field should be 0. So due to first bar magnet, it will be downward. So minus mu naught m 4 pi 2d whole cube minus mu naught 2m 4 pi d whole cube plus this will be mu naught m dash 4 pi 3d whole cube. This should be equal to 0. So mu naught 4 pi d cube you can take outside. Or that everything will be, so this will become eliminated. So this will become 2 cube minus 2 this is m, no? Here m will come 2m, this m dash. Solve for this, we'll get the required answer. So like this, some different things. Just I think you would do one thing. Randomly you assume 5-6 problems on your own, different orientation. Keep it aside this topic. So anything if they ask you field due to more than one bar magnet, as this approach I have, I can find out. If they ask you some arbitrary here, as you can manage, you have to go for that particular formula. Okay, this is about the calculation of this one. So can we replace now, suppose say 2-3 bar magnets are there, if they are tied, how to replace the, like a 2-3 bar magnets kept at a short bar magnet kept at a point. Suppose if there are 2 bar magnets are there, one is m1, dipole moment these are. You can write the resultant dipole moment as m. In this case, what is m? m1 plus m2. With the bar magnets, if the dipole moments are placed like this, they can't be like this. What you should do, you should take a adhesive tape and you have to wind it, no? Am I right? I think if you take the north, that one they'll try to repel. So for that purpose, you should take a thread and you should bind it. if they try to repel away, then what is the effective dipole moment? This is the formula. In this case, what is the effective dipole moment? In the direction of the greater one. Similarly, if the magnets are arranged like this, then what is the resultant dipole moment? The resultant dipole moment is given by m is equal to root of m1 square plus m2 square. And what is that angle tan theta? m1 by m2. You can replace those two short bar magnets. They should be strictly, and they should be in contact. They should not be separated far away. And now, if the bar magnets are oriented like this, some angle, as dipole moments are what? Vector quantities. So the resultant dipole moment is given by m1 square, m2 square, 2m1, m2 cos theta. You can replace that with an equivalent bar magnet whose dipole moment is equal to this much here. In numerical solvent, sometimes we get a bar magnet. Rather than fighting with individually due to m1, m2, no, you can replace with one resultant and you carry on the problem further. The orientation, how that m bar should be oriented, theta, that theta is given by this one. Similarly, you should calculate that the resultant m bar will depend on m1 and m2. Somewhere it will come like this. I think you go back to the vector side here. Then angle made by m bar with 1 tan phi. Use that vector addition of two vectors formula. Calculate the angle made by m bar with any one vector. So I think I'll give some rough diagram. You work out later on. This is theta, no? The resultant m bar will be like this. Calculate that angle phi, tan phi. Theta is angle between this dipole moment. So these are some generalized things can be asked for you. Replacing the bar magnets. I'll stop here only. I think chemistry class, you can go for it. Huh?